Hello, I'm Samathy Barratt. My details are at the bottom there. This is my first talk, aside from last night's lightning talk, so be nice. I learned stuff in Angela's talk just a minute ago, so I now have new opinions, which may or may not be useful. So this talk I'm going to be attempting to get you to think about where you should do type checking. I want to make you aware of the benefits and disadvantages to doing it and not doing it, and hopefully by the end you should be able to go away and intelligently consider whether it's your responsibility in the piece of code that you're writing to do some type checking or not to do some type checking. This is mostly on the subject of dynamic data, where the type of the data could be several different things in a different sense to static type checking, which is something that I won't be covering. So, to check or not to check. So you're writing a function in Python which takes two integers and returns their sum. You could write it like that, where input and input2 could be any pieces of data. They could be integers, they could not be integers. Somebody could pass you a string, and then you might try to add it. Or you could write it something like that, where we check the types to make sure it is an integer and that we can perform what we want to perform on that. You might be interested, when I was looking at this, I did some time checking, and actually the second side there takes about 1 second to 2 seconds longer to execute than not checking the type, which is surprising. Oh, yes, okay, there we go. Yeah, so this screenshot here shows the code that I was running and the time that it took to run each version of the function. So let's start looking at the disadvantages and advantages of checking or not checking. Let's start with checking it. You gain ease of use. So, oh dear. You're not risking the programmer calling your callable with the wrong data and causing a really hard to diagnose error. You catch it for them, return something easy to understand that allows them to continue the execution of their program if that's something that they can do. You gain heightened safety. Your function might be able to deal with the wrong data, and although it returns some garbage, the function operates in a reasonable way. For example, adding two strings together would just concatenate them and return the string. But the function that called your function might not be able to deal with strings because it was expecting an integer. So down the line, other parts of your program might not be able to cope, which could cause quite serious issues. So yeah, you'll get assured output expectations, which is always useful. So the advantages of not checking is definitely speed. As I showed you earlier, it can take significantly longer to do checking on using the type function. And you get less chance of buggy code because you've got less lines of code. So usually less code means less chance of bugs. And you end up with less complexity because more lines, more complexity, harder to maintain, that kind of thing. So the disadvantages of checking or not checking. If you're checking your code, you end up with pretty much the opposites of not checking. Increased time, increased complexity, and chance of bugs. But not checking, you get quite significant increases in the possible amount of errors. So attempted to perform unsupported operations, I don't know, trying to perform a find method on an integer because you were expecting a string, or accessing a dictionary value when using a float as a key. Or you could encounter trying to perform an operation and returning an erroneous value that the caller then continues to use because it was expecting something different out, which could suck incorrect pieces of data into the bowels of your program and result with errors a lot further down the line than where the actual issue is, making it really hard to debug. And maybe even your program sends data to an external system, a C library, or across the network, which maybe that kind of thing won't deal so well with issues with types, especially C libraries, where it's statically typed and you pass it an integer when it was expecting a character. Who knows what could happen? Okay, when should you check and not check? Whose responsibility is it to check the types of data? I'm going to need a diagram for this, and that's something that I made. So here we go. We'll start with the data entry point to the program. So this could be through a command line argument, could be a file that we're interpreting through a network input, any data into the program at any time. It's not important to check the types here when they initially come into the program. We can put them in temporary variables or whatever, because next we're going to put our data into some data structures. This might be classes, it might be dictionaries, whatever is the most useful way to represent the data that you've had input into your program internally into the program so you can do stuff with it. The next stage is the data processing ingestion point. So this is a gatekeeper point of the program where past this point we're going to be working on the data. We're going to be messing around with it, making some changes, processing, doing some addition on some integers, whatever. So we need to check things here because we know that after this point, if we check things on ingestion, we don't have to check ever again because no more data is coming into the data processing stage. So we can avoid doing any more type checking while we're doing data processing because we haven't added any kind of dirty, unchecked data. So when we finish processing, we go back around again, input into our data structures, put it back into our classes, our dictionaries, and that kind of thing. And then we probably want to output the data to somewhere useful, like a user interface, or maybe a network, or a file, or something else. If we're putting it out to a file or a network, it might be a good idea to check the data before we output it there. But it's not essential because we probably checked our data when we put it back into the data structures after processing. Okay, right. Example time. So this is a semi-real world example of a program that I've been working on at my job. In this case, the data entry point is a large amount of log files from a supercomputing cluster. So the entry point is opening all those files and putting them into some data structures, like classes for users, classes for jobs, with values representing, I don't know, amount of jobs completed by a user and that kind of thing. So we need to perform type checking at this stage to ensure that we aren't ingesting any data that we didn't expect from the log files, because the log files are produced by an external system, so we're not completely sure what format those might be in. So we should probably check before we start creating user classes out of data that is an integer, just because that happens to be what the scheduler spit out of the cluster. So once our log files have been parsed and put into the data structures, they get pushed into a processing stage that gathers metrics on the data, such as jobs submitted per department, users with the most failed jobs, and a few other useful things. So that goes all the way around and goes back into our data structures, ready for extraction out of the program to a user interface in this situation here. And we can be sure that we've checked our data types when we put them into the data structures. So all of the processing is safe. We're not dealing with any dirty data here. Yeah. So now we've gone through where one should check their data. Let's go back to the original question. Yep. Type checking. Whose responsibility is it? And is it your responsibility? To work out whether it's your function's responsibility, you need to look at where your function is receiving data from and where it's sending its data to. So, yes, check your data input if your function takes data from a source with an unknown state. So that might be a user, files, network. In my case, it was log files coming off a cluster. And I checked the data to make sure that it was going to be safe to go in. But no, you don't need to check your types. You don't need to waste time. If your function takes data from a source with a known state, so a pre-checked part of the system that hasn't been modified by dirty data coming from an unchecked part of the system. Something that I'd like to cover is definitely 3.5 type hints, which, although they work very well for allowing you to specify the type of data coming into functions, they are static type checking. So it's a bit hacky to make it work for a function that can deal with multiple different kinds of data. Although, as Angela showed, it's possible. And it's also not very good for dealing with dynamic data, because you can be ingesting anything. You can be taking anything in. But they might be for you, they might be useful, so check them out and apply them to your own code, see what happens. So yeah, I'm done. I'm not sure how I'm doing on time because my clock stopped. But yeah, if you have any questions or any suggestions, then please let me know, because I'm relatively new, I'm quite naive, so help me out and I'll see if I can help you out with answers to questions.
Thank you very much, Samathy. So can I get a queue of questions up here, please?
Hey, I'm just kind of wondering how you interpret sort of the system and the ownership. So, for example, project I'm working on, there's, a web framework and then some queues running on Celery. Would you be concerned about the Celery tasks, making sure their data's good, or are you assuming that, we'd probably not put bad data onto Celery by that point, even though that might have been hours ago, perhaps?
So where does the data come from that gets input to Celery?
So it all came from our web client, which was sanitized when the post data comes in, and then put on the queue, gets picked out later.
So if you're 100% sure that data is not going to have been touched by an unsanitized input, so you've already checked it before it's been input, then it's probably safe. But because you're going from one system to another, having the entry point to the system checking the data types might be a good idea if you want to really be sure. But I don't know.
Okay, cheers.
Thank you for the question, though.
Hi, I want to double check types in runtime. It's possible.
What was that?
Double check types in runtime. It's possible.
Mm-hmm.
Yep.
I'm not quite sure what you mean. Can you explain it a bit better?
Types in runtime?
In runtime, yeah.
So how can you check types at runtime as well as doing them statically in your code?
Like I might py something.
Okay, so checking them at runtime, you can use the type method on an object, and it will give you what type it is, which is...
You mean annotate?
Pardon?
Annotate. All object in Python are that annotate object, but it's impossible.
Should we talk about this afterwards?
Okay.
Yeah.
Thank you.
Any other questions from anybody? If you come up in queue, we can get through them faster. No pressure.
There seems to be talking about maybe type checking, and then there's data checking. Normally, I write scripts, a lot of them. You check on the input, and you know what you're writing, so the algorithm is correct by design if you get the correct output. Right? So you check on the input, and it's totally different from type checking. You know, this is data validation that you do on the input.
Yeah.
Just the two things.
Yeah.
So, sorry about that.
Okay.
Just a question from my side. You talked a lot about you can check less if you know that your data is coming in clean.
Yeah.
Do you have any advice on like how you can know that your data is coming clean? Because I'm paranoid. I love the people I work with dearly, but can I trust them for that? Really? I mean, are there ways I can automate this? Do I have to go on faith?
So how do you know if your data is coming in clean? You don't unless you know other people are following some kind of model where they know that they need to check the data types, or they know that they don't have to. So it's about it's about everyone making sure that they know whether it's their responsibility or not. It requires a team effort, I suppose.
Excellent. Right. Oh, one more. We just have time for one more. Yep.
Okay. Going on his question, is it perhaps? I was wondering if you think this can be complemented in some way with some kind of testing to ensure that data has correct formats in some interfaces, or do you think that testing could be useful to do this or not?
Yeah, there's no reason why you can't test it by running unit tests and inputting data and checking whether you have the expected output from all the different levels of your piece of software. So yeah, there's no reason why you can't use some testing methods to make sure that it all works.
Excellent.
Okay.
Thank you very much.
Thank you.